Hello बच्चों, how are you? I hope that you all are good and enjoying the study. Myself Virendra Kumar and you are watching the Hero Cosmos directly live from the Lucknow Center. This video is related to the physics of mechanical properties of fluids. So already you have discussed in the first episode of this chapter related to class 11 physics, chapter number 10, given in your NCERT textbook. We have discussed the compressibility, incompressibility, fluid types, and the interatomic forces impact on the compressibility of the fluids and so on. Now I am going to move forward, and already we have discussed this density of the fluid through this given table, and that is important, may be asked in your competitive examination, mainly NEET exams, because NEET as well as also important for the IIT-JEE exam, because you know in the MCQ type questions they are giving the tabular forms and they are asking the students to match the related properties. So you can remember this data and it may be useful for you. Now here is an example that is related to the femur bones. Already this type of question was given in the mechanical properties of solids. Same terminology question is given here in case of what? Mechanical properties of fluids. Here it is asking the average pressure. There it was asking the stress and elasticity related problem. So here I would like to explain example 10.1. So example 10.1 for you. The two thigh bones known as femur, each of cross-sectional area cross-sectional area 10 cm square support the upper part of a human body. Of mass 40 kg. Estimate the average pressure sustained by the femurs. So, if you draw some diagram for a human being, and this is the femur, thigh bones, and so if someone is here, so total 40 kg weight of this person is on these two femurs. So it is being asked that find the pressure felt by these femurs or sustained by these femurs. So it is asking the pressure, average pressure. Average pressure is given by force per unit area. So it is asking the average pressure over the femurs. That means cross-sectional area of the femurs you have to be calculated. So cross-sectional area of total cross-sectional area. Total cross-sectional area of both femurs. Because whole weight is on the two femurs, both femurs is each of cross sectional area is 10 centimeters square. Mind it. So total cross sectional area is 2 times 10 centimeter square, and you need to change this centimeter square into meter square. For that, what you will do? You will calculate. You will multiply this by 10 to the power minus 4, and this will make the meter square by centimeter square. So, so final cross sectional area is 20 into 10 to the power minus 4 meter square. This is the cross sectional area of the combined femur. So you find the cross sectional area. Now the force. Force is given in terms of the mass multiplied by the acceleration due to gravity. So mass is given 40 kg and acceleration due to gravity is 9.8 meter per second square. So kg meter per second square is the Newton, and this will give the how much? Almost 40. So 390 Newton, 392 Newton. So what is the pressure? So substitute these values. So you will get the pressure average. P average is equal to 392 Newton upon 20 into 10 to the power minus 4 meter square, and this will be around 10 to the power 3 Newton per meter square, right? So you can write this as a, if you write this in terms of 1.96 into 10 to the power 5 Newton per meter square, and this will be nearly equal to 2 into 10 to the power 5 Newton per meter square. So this way you can calculate the problems, right? So this is the related to the example 10.1, and it is asking the pressure. In the similar manner, you can calculate the pressure for the given question. So let's move. Now the Pascal's law. So Pascal's law is important. Pascal's law is the important law related to the fluids, and we will know about this in detail, and we'll try to understand what is the significance of this this law. So Pascal, who is the Pascal? Not Rascal, Pascal. So he was a great French scientist. Full name is Blaise Pascal. observed that pressure in a fluid at rest. So what he observed? So first, what he considered that fluid at rest, that means static fluid. He is talking about the static fluid. He is talking about the static fluid at rest, right? So let me send the yes. So Pascal took the static fluid at rest, and he proposed some rules related to the fluids pressure. So what are the what were those rules that is known as the Pascal's law today? He proposed that first point, if you are considering, suppose you are taking the fluid, so first point that if you are considering the points in a fluid at the same level, then the pressure at all those points at the same levels will be equal. So if you are considering the points at this, at this, at this, at this, at this, at the same level, or you can say at the same height from the ground, we will be having the same pressure. So that is the first point, right? And second is that pressure at any point in the fluid will be uniform from all directions, right? If you are taking some point here, so pressure from each direction at this point will be uniform, or this point will be experiencing the uniform pressure from all directions, right? So this is the second point. And third point is that the pressure originated from any point in the fluid will be reaching to the walls of the containing container that is containing the fluid undiminished. Undiminished. That means pressure is not going to be lesser at any cost. It will be reaching to the same pressure at the boundaries. And these properties are very well exploited in our industrial applications. So let us prove this Pascal law with some examples. So I have mentioned the 3 points. P same at same level, same at same level, same height. Second point was that uniform. Fourth point, undiminished movement, yeah, or undiminished propagation of pressure.
These are the important points, or you can say the Pascal's law, right? And we can prove this by taking this picture. So basically, this picture, I want to zoom it so that you can see very clearly. So see here in this, to prove the Pascal law, proof of Pascal law, Pascal law. We are we are considering the prismatic element of this fluid only. This element is not from the outside, it is inside of the fluid and it is the part of the fluid. So, what does it mean is that let us assume that and or assume that a small, very small element of fluid in form of the prism. And what are the importance of taking the prism? Shape. You can take any shape element, spherical or tilted, but for the convenience of proving this law, Pascal's law, we are taking the prismatic shape element, and this element is so much small that gravity at each point of this element is uniform and you can say negligible. Uniform, it is negligible, but also I considering that if it is there, it is uniform, but it is so small that gravity on this element is negligible, right? Okay, so why, so element of consideration is very small, gravity is negligible, right? And we are taking the right angle triangle prism because we want to prove that the pressure from all direction is uniform. So here by taking this shape we can easily decompose the forces pressure into perpendicular components and that can cancel easily. See, this ABC is the front face and DEF is the back face and ACFD is a diagonal face. Similarly, ABED is the vertical face and this BEFC is the horizontal face of the prism, right angle prism, right? So suppose this area is the AB and this area is the A and this area is the AC, right? And because of the fluid, each area is facing pressure, right? And all the pressure on each area pressure is acting perpendicular to the area. I have already mentioned in the previous episode related to the mechanics of the fluid that pressure of the fluid in the on the object inside it always act perpendicular to the area. Here that principle is applied. So pressure is perpendicular to the area. It doesn't matter the orientation of the area. So pressure, and because of and that pressure, see, if the pressure is acting on the area AB, so that pressure PB can be defined as FB by AA, AB, and similarly you can define the other pressure acting on the other faces or area. So PA is equal to FA upon AA, and PC is equal to FC upon AC. बच्चों, here it is important that you understand each and everything clearly. So I again attract your attention that we are taking the prismatic element for our convenience, so that if we resolve the pressure, if we resolve the forces, they can easily be what resolved into different components, vertical and horizontal, and they can cancel each other without any cumbersome. So that's why, see, these are the pressure in terms of the force and the area. Now, if you are, see, if this is the angle theta 1 and theta 2, and if we assume that AB and BC is equal, AB is equal to BC, then theta 1 will be equal to theta 2. See, now if we resolve, yeah, now I I have to keep the direction of the arrow in this way, and direction of this arrow in this way. So because the direction of the force AB is in this way, so after resolving the component horizontal and vertical, the direction will be in this way and this way. So you can see that here, and this suppose this is the angle theta. How it can be theta? You can see that this is the angle, this BC is parallel to this, right? And if we are drawing the, this is theta, and you want to know the direction, this theta. So let me assume that this is theta. So this horizontal component will be FB cos theta, and this vertical component will be AB sin theta, right? Hmm. See, if you want to resolve this, this will be what? If this is theta 1, this will be 90 minus theta 1, right? So if we draw this here, so this will be what? 90 minus theta 1, this will be theta. So, right. So in this way, it can be understood. This will be 90 minus theta, 90 minus theta 1. Since I assume that for AB is equal to BC, in that case theta 1 is equal to theta 2. So this will be the general theta. So this will be 90 minus theta, and this will be theta. So now our purpose is to balance the forces. So here from the diagram, it is clear that FC is equal to FB cos theta, and FA is equal to FB sin theta. FA is equal to FB sin theta, right? Similarly, you can this you keep at one place. Similarly, in terms of area, this area, if you take the area as a vector quantity, then F F sorry, then AC is equal to AB cos theta and AA is equal to AB sin theta. How? See, since this force is acting perpendicular to this face ADFC, so AB direction will be always perpendicular to the surface vector quantity. If you are considering the area as a vector quantity, then this AB will be what? Along this direction, right? So in that way, and this area will be along this, and this AC will be along this. So in that way, if you decompose the vector AB into the vertical and horizontal components, so in the similar fashion, you will get AC is equal to AB cos theta, AA is equal to AB sin theta, right? I hope that you understood this. In the similar fashion, as we did for the FB, we can resolve the AB into vertical and horizontal component like AB cos theta and AB sin theta, but the direction of AB cos theta and AB sin theta will be in this way, and similarly they will be cancelling this component AB cos theta and AB sin theta, right? Okay, you got it. Yes, कर रहे हैं. Okay. So similarly, you can resolve the aerial vector into the horizontal and vertical component, and you will get the AB cos theta is equal to AC and AB sin theta is equal to AA. Right. So you get this relation here. Right. Now dividing the corresponding FC upon AC, you will get what? FC upon AC is equal to cos theta will be cancelled out with cos theta, AB and AB. So FC upon AC is equal to what? FB by AB. FB by AB and FA upon AA is equal to FB by AB. FA upon A sin theta sin theta. FA upon AA. FA upon AA is equal to FB upon AB. So this means that taking this together, we get that FA upon AA is equal to FB upon AB is equal to FC upon AC, and these are nothing but the PA is equal to PB is equal to PC. So we just prove that pressure on every point on this element are equal, and as you know that we have assumed this element very small, That means it may be the point. This element we have enlarged to visualize the elemental points, but it is actually the small point. That means each and every pressure acting on this element are equal to each other. TA is equal to TB is equal to PC. And that is the Pascal's law, and just we proved this. O P small. Okay, it takes time. So hence pressure exerted is same in all direction in a fluid at rest. So we have derived that if pressure is acting in this direction, 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 all are same. All are same. Pressure exerted is same in all direction. Same in all direction in a fluid at rest. So constant is that fluid should be at rest. Fluid should be at rest. If fluid is not in rest, pressure can't be same. Fluid is in rest. Okay. Fluid should be in rest. So, pressure is not a vector quantity, that is also coming from this Pascal's law. Now, no direction can be assigned to it. The force against any area within a fluid at rest and under pressure is normal to the area, right? Regardless of the orientation of the area. The force is always perpendicular to the area. Now consider a fluid element in the form of horizontal bar. So up to now we had considered the element in the right angle triangle prism, but if you consider the element as a horizontal bar, this is the uniform bar, uniform horizontal bar, and if this is in equilibrium, it is in equilibrium, and, and the fluid is in rest. So that means the pressure acting on these two ends must be equally balanced, must be equal, right? That is, it is saying at two ends must be balanced, or the pressure at two ends must should be equal. This proves that for a liquid in equilibrium, the pressure is same at all points in a horizontal plane, right? Or in other words, suppose the pressure were not equal in different parts of the fluid, then there would be a flow as the fluid will have the some net force acting on it, right? So start from beginning. We assume that horizontal bar is in the equilibrium position in the fluid, fluid at rest. No, it is not assuming that. See, it is assuming that this bar is in equilibrium position, and because of this balanced two pressures, the net forces acting on this uniform bar horizontally, yeah, are equal. Are equal. That means there is no flow of the fluid, because if there were flow in the fluid, the forces would not be the same. So that is the conclusion. If the bar is in equilibrium, the fluid must be in rest, right? And if fluid is in at rest, the pressure acting on the body inside the fluid will be uniform from all directions, right? All equal in the horizontal plane, right? Suppose the pressure now, hence in the absence of flow, the pressure in the fluid must be same everywhere in a horizontal plane. So it is proving that in horizontal plane also pressure is same. If it is pressure at 1 Pascal here, this will be same at the same level here. So that is the point of consideration, right? Okay. Now come to the another point of Pascal's law that is given in the in your textbook. Very here. Note it. This is the another form of Pascal's law, and it has many applications in daily life. What is the form? A. We can say what Pascal's law. We can say that is the Pascal's law, and it is the Pascal's law. In other words, but whenever external pressure is applied on any part of a fluid contained in a vessel, right? Whenever external pressure is applied on any part of a fluid contained in a vessel. So if you are containing the fluid in a vessel, this is a vessel and it is containing the fluid. And if you are applying the pressure, suppose this is P. So whenever external pressure is applied on any part of a fluid contained in a vessel, it is transmitted undiminished and equally in all directions, right? So if you are applying the pressure at this point, so this pressure is going to transmit in all direction. So point is in all direction uniformly, all direction equally. Uniformly means equally, in all direction equally, right? Second point, without diminished. That means undiminished to the wall of the vessel. To the wall of the vessel. On yeah, if you are applying the pressure here, so it will reach the wall of the vessel. It will reach the wall of the vessel equally and undiminished. Undiminished means that if you are applying the 5 atm pressure, then the wall will also feel the same pressure. There is no decay or decrement in the pressure because of the fluid quantity. Right? That is the wonder of this Pascal law. And this very property is exploited in using the hydraulic brakes, hydraulic lift, right? Right. So I discussed the Pascal's law and its significance in detail. We derived the how the pressure at any point in a fluid are equal from all directions. Right. Now come to the previous point. What? See. here. The point is that the pressure variation with depth. Pressure variation with depth. Variation of pressure with depth. Variation of pressure with depth. With depth. So Pascal's law say that at points, every point at the same level, pressures are uniform, pressures are equal. It is talking about the same level points. Maybe many points are there, but they are having the same level. Then the pressure is equal. But what if the levels are different? So if you are considering the vessel containing the liquid fluid, and if you are considering the different levels, suppose you are considering this point A and you are considering this point B. So will the pressure at A and pressure at B will be same? No, big no. Because the levels of this point A and B are not same. They are at the different levels, and therefore they are at different pressure. The points in the fluid at the point A and B are experiencing the different pressure. So how much pressure variations are there? So let us calculate. Let us find out. So for that, let us consider the cylindrical shape element in this fluid. Cylindrical shape element. Uh, I draw. So no need to draw the element. It is given. So let us take this. So it is not coming. So why it is not coming? Hmm. See. So we are taking the this cylindrical element. Cylindrical element of this fluid only. Cylindrical element of this fluid. This is not the any other thing, but this is the part of the fluid. Cylindrical element is the part of the fluid, right? Now, now consider the now consider the 2 points A and point 1 and point 2. This is the point A, 2, and this is 1. And the difference, or you can say the height of this cylinder is h. So cylindrical height of cylindrical element is h, right? So and density of fluid is rho. Height was h. Height of cylinder was h. No. Now come to the point. Suppose this point 1 is experiencing the pressure P1, and this point 2 experiencing the pressure P2. So difference between the two pressures will be what? P2 minus P1. So difference of pressure at points 1 and 2 is equal to P2 minus P1. Right. Now, if the area of cross section of cylindrical element is A, then the force acting on this element, acting on this element due to fluid, due to other parts of the fluid, due to other parts of the fluid is equal to P2 minus P1 into A, because force is equal to P2 minus pressure into area. So this is a force, and this force, see, this pressure P1 will be acting downward and this pressure P2 will be acting upward. So resultant pressure is balancing this element, fluid element, cylindrical fluid element. So this is the pressure, that is P2 minus P1, that is balancing the element in the fluid itself, right? So, and what this pressure difference is balancing the element? It is balancing the weight of the element. What? Weight of the element. So this pressure is difference is balancing the weight of the element, and that is given by am into g. Right, weight of the element, mass of the element is m, mass of the element is m, g is the acceleration due to gravity. So we have now P2 minus P1 A is equal to mg, and m is equal to, by definition, mass density is equal to m by v. So m is equal to rho into v, g. Okay. Rho into v. So what we get, P2 minus P1 into A is equal to rho Vg. This is the formula. Now V is equal to area of the cylinder, क्रॉस सेक्शनल एरिया, बेस, जो सिलेंडर का जो बेस है उसका यही हमारा ना है, इसका बेस क्रॉस सेक्शनल क्या है, ए है, एरिया पूरा, लेंथ नहीं बोल रहा हूँ, लेंथ समझेंगे तो बच्चे कंफ्यूज मत होना भाई. दिस इज द बेस क्रॉस सेक्शनल एरिया, राइट. ओके, एरो यहाँ, इसका मतलब ये नहीं है कि यहाँ से पूरा बेस एरिया. So base area into height will give the volume of the cylinder element, and that is G. So we get P2 minus P1 is equal to A cancel rho G H. So this is the pressure difference at the 2 points in a fluid. 2 points, that was in terms of the point 1 and point 2 on the elemental cylindrical element, cylindrical fluid, right? So we get this P2 minus P1 is equal to rho gs. Now, if P1 is equal to PA, what does it mean? PA is the atmospheric pressure. If atmospheric pressure, that means P1 was the pressure at the point 1. That means if we shifted point 1 at the surface of the fluid, if we are considering this element P1 at this, we shifted this element to this level and this point comes here, then if this point come here, then what happens? It will be experiencing the pressure equal to the what? Atmospheric pressure. So that is the point. If P1 becomes PA, that means point 1 comes at the surface of the fluid, then and if you write P2, P2 is equal to P, then in our case P2 minus P1 is equal to rho GH, and that is P minus PA is equal to rho GH, that is P is equal to PA plus rho GH, right? And so we get the two terms. First is the P minus PA is equal to rho GH, and this is the P is equal to PA plus rho GH. These two are different terms. So this is known as the gauge pressure, and this is known as the absolute pressure. समझ रहे हैं? This is known as the absolute pressure. So what is the gauge pressure? The pressure at any point inside the fluid we are measuring only because of the column of the fluid. So gauge pressure is the pressure inside the fluid due to the column of the fluid only. If you are taking the column of the fluid and that column, the point is here, you are measuring the pressure here. So you want to know the pressure at this point. So that will be due to the entire column of the fluid just above it. Not we are considering the atmospheric pressure, only due to the column of the fluid just above the point of consideration. So that is the gauge pressure. And if you want to know the total pressure at this point, we will include the atmospheric pressure, right? So what we see here, two important things. P is equal to PA plus rho GH and P minus PA is equal to rho GH. So this gauge pressure depends on depends on what? Density of the fluid, acceleration due to gravity of the earth, and h of the height of the column, height of column of fluid just above the point, acceleration due to gravity. and density, mass density, right? Mass density. It is not depending. See, mind it here. The pressure difference at any point inside the fluid, that is the gauge pressure, doesn't depend on the area of the fluid column, right? It is not this is not depending on the area, right? Only depends on the mass density, acceleration due to gravity, and height of the column. It doesn't depend. It doesn't depend on area of fluid column. Fluid column. So, what is the significance of this conclusion? What is the significance? That means no matter what is the shape of the fluid column, the pressure, gauge pressure will be same. No matter what is the shape of the fluid column. If you are taking the shape of this, if you are taking the shape of this, or if you are taking the shape of this, anything, any shape. So point, so the if these are the points at the same elevation, then pressure at this A, B, C will be equal, right? If the height is same, height of the column is same, and density is same for all the entire fluid. So that is a very important thing. आप कंटेनर को उल्टा कर लो, पुल्टा कर लो, जो कॉलम फ्लूइड कॉलम आप ले रहे हैं उसके शेप पर फर्क नहीं पड़ता, शेप की वजह से प्रेशर, गेज प्रेशर पर कोई फर्क नहीं पड़ता है, ठीक है. दैट इज अ वेरी इंपॉर्टेंट आउटकम ऑफ दिस discussion. Now, so this is the thing. Now, absolute pressure, mind it. It is mentioned in your NCERT text. Absolute pressure is PA plus rho GH. Atmospheric pressure, absolute pressure, absolute. It is used to ask in the exam. Absolute pressure is equal to what? Atmospheric pressure plus gauge pressure. Right? So that is the thing. Now, देखिए आपके टेक्स्ट बुक में क्या लिखा है, बहुत अच्छा चीज लिखा है. द हाइट ऑफ द फ्लूइड कॉलम इज इंपॉर्टेंट, नॉट क्रॉस सेक्शनल एरिया और बेस एरिया और शेप ऑफ द कंटेनर. सो फॉर द गेज प्रेशर or the total pressure, because the gauge pressure, total pressure depends on the gauge pressure, so absolute pressure also not depending on the cross sectional area or base area or shape of the container. किसी चीज में फर्क नहीं पड़ता है. जैसे मान लीजिए सपोज आपने एक लाइन ये खींच लिया और एक लाइन ये ले लिया, सपोज कीजिए आपके एक जो है ऐसा कंटेनर ले लिया, आपने एक सिलिंड्रिकल कंटेनर ले लिया, आप जो है एक जो है स्फेरिकल कंटेनर ले लिया, ठीक है, कैसे भी डिस्टॉर्टेड भी, लेकिन इनका यदि फ्लूइड कॉलम का हाइट सेम है और डेंसिटी भी सेम है, तो प्रेशर जो है इस पॉइंट पर सेम ही लगेगा. It doesn't depend on the shape or the cross-sectional area or base of the container. And this is known as the hydrostatic paradox. Very important terminology, hydrostatic paradox. Note it. WA upon capital A is equal to small w upon small a. What are these things? That is the outcome of the hydrostatic paradox result. If we consider some situation, suppose uh, let me bring some picture from the net so that it will be more clear to all of you. क्या हुआ, नेट ही नहीं आ रहा? ऑन करो भाई, कैसे हो गया? हाँ, so let me hydrostatic hydrostatic paradox. See, I want to uh, clear up for some. Yes, suppose I want to take some picture. What this? So let us crop this image for your. So just I want to illustrate the things. See, so see, and this is the thing I wanted to explain. So we are discussing the hydrostatic paradox. Hydrostatic paradox. So suppose the weight. Suppose I have put some heavy weight over this surface. Heavy weight over this surface. Suppose capital W, right? And the area of cross section of this base is capital A. right? And if you want to add some small amount of same fluid, what the fluid is inside this, suppose the density is rho, same rho density, we are adding the small amount of fluid, suppose this is the small w, and the cross section of this small tube is small a. Then if by adding the small amount of fluid, this level of w weight will be raised, right? To balance the column of the fluid again. So in that equilibrium, we will get this result. The point is that in that equilibrium we get this result. Okay, so you can calculate the weight of the body that can be balanced by the additional uh, fluid that is being added. So you can decide by what amount I can lift what amount of mass or weight, right? So this is very useful formula for your competitive examination point of view, right? Now see, this is the hydrostatic paradox explanation, one part. Another part I am going to discuss that. I told you that it doesn't matter the shape or area of cross section or base of the vessel in which the fluid is filled if they are having the connection or having the same level. So if they are connected, they are achieving the same level. They are achieving the same level, same level, and by just a layman can think that this step is different from this, so level of the fluid will be different. That is the paradox here, the hydrostatic paradox. No matter what shape you are choosing, the level of, if they are all connected, the level of the fluid will be same, right? This is the hydrostatic paradox, and we can utilize this paradox to calculate the lifted weight by applying the small amount of weight or load, right? And this is utilized in the wire hydraulic lift and hydraulic brake, right? So now here it is also explained in the NCERT textbook. See from the picture, you illustration of the hydrostatic paradox. The three vessels A, B, C contain different amounts of liquid, all up to the same height. So it is true that different shape vessels are going to accommodate different amount of fluid, but the level must be same. The level must be same. समझ रहे हैं? So that is the hydrostatic paradox, and by utilizing this hydrostatic paradox, we can calculate this lifted weight or resultant force. So weight is nothing but the kind of force now. So you can calculate. So mind it, note it. This is the important formula, and I describe what are the W, capital W, small capital A, small W, small a. So note it. It is very important, right? Now we have discussed the gauge pressure hydrostatic paradox. Now let us take up the example 10.2. What is the pressure on a swimmer 10 meter below the surface of lake? Then we'll calculate this atmospheric pressure and gauge pressure. We have already discussed, but this is the uh, some value. So let us take up the example 10.2 for you. Example 10.2. So I am solving these examples because this may be given in your textbook, but I want to elaborate the solution so that you can understand in a better way. What is the pressure on a swimmer 10 meters below the surface of a lake? So some swimmer is, this is a pond, lake, and some swimmer is swimming here 10 meters below the surface. So it is in the liquid water. लेक में वाटर ही तो होगा, fluid. So 10 meter below the surface. So what kind of pressure this swimmer is feeling, sustaining? So you can calculate. It is asking the gauge pressure. What is it is asking? Gauge pressure or total pressure? What is the pressure on a swimmer 10 meter below the surface of a lake? So this is the press, absolute pressure asking. So pressure on swimmer P is equal to absolute pressure P is equal to PA plus rho GH. So it is, this is 1.013 into 10 to the power 5 Pascal. 1 atmospheric pressure is this much amount. So it is here written. 1 atmospheric pressure at the sea level is 1.013 into 10 to the 5 Pascal plus rho, water density 1 into 10 to the power what 3 kg meter per kg per meter cube, and H 10 meter. So Pascal is Newton per meter square. Unit wise you can check 1.013 into 10 to the power 8 into 10 Pascal Newton per meter square into kg upon meter cube into meter. So what pressure is Newton per meter square. So sorry. So this is not going to be multiplied. It is added. Uh, it is added. This I thought this is multiplication. So see, so 1.013 into 10 to the power 5 Pascal प्लस 10⁴ पास्कल, ऐसे हो गया। तो 10.13 into 10⁴ plus 10⁴ Pascal. So you are left with 11.13 into 10⁴ Pascal. इतना प्रेशर जो है वो स्विमर क्या करेगा, फेस करेगा। कितना आया? अच्छा, रो जी एच, जी की वैल्यू नहीं रखा था, रो जी, जी भी तो रखना है, जी जी जो है रखना है, तो एक 10 और जुड़ जाएगा भाई, तो ये 10 जुड़ गया, तो आपका हो गया ये 10, 20 हो गया, ठीक है, सॉरी, दिस बिकम्स 20.13 into 10⁴ Pascal. You can write this as a 2 into 10⁵ Pascal. So by this example, what is emphasis here is, note it, this example is highlighting something. So when the person swimmer was here, right? When he was here, he was feeling facing the pressure 1 atm, 1 atm at the surface of the pond. But as he dipped down at the level of 10 meters below the surface, he is facing the 2 atm. Pascal is 2 atm because 2 into 10 to the 5 means 2 atm. 2 into 10 to the power 5 Pascal means 2, or 10 to the 5 Pascal means atm, 1 atm. So 2 atm. So 2 atm pressure he is feeling if he is going down 10 meter below the surface. If it is going below the 20 or 1000, so 1000 means 10 times more. 20 C. So there is a 100% increase in the pressure. By going down 10 meter, the pressure becomes twice, right? By going, so at a depth of 1000 meter, the increase in pressure is 100 atm. 10 meter gives you 1 atm extra, 1 atm extra. Let us understand this. 10 meter depth gives you, or gives you 1 atm extra pressure on you, extra pressure. One 10 meter depth gives you 1 atm extra pressure. So 1000 meter depth will give you how much? ए भाई 1000, 1000, 1000, 1000 meter will give how much? 100 atm extra pressure. 100 atm extra pressure. Extra pressure. That is the point. यदि आप 1 किलोमीटर डेप्थ पे नीचे जाते हैं, जो डाइवर होते हैं उनको जो है 100 मीटर 100 एटीएम जो है एक्स्ट्रा प्रेशर फेस करना पड़ेगा, एक्स्ट्रा प्रेशर, राइट? दैट मीन्स टोटल प्रेशर विल बी 1 प्लस 100 एटीएम एक्स्ट्रा हो गया, ठीक है। Submarines are designed to withstand such enormous pressure, right? So, submarines used to be below the water surface, and if these submarines are going into deep in the ocean, the body of the submarines must be facing the pressure due to this water column, right? So, if the submarines is made up of the very not so strong material, it may be imploded, right? So, to withstand such enormous pressure, submarines are made up of the strong material, and here the elastic properties of the materials comes into account. So, you can correlate the two chapters simultaneously: mechanical properties of solids and mechanical properties of fluids, right? So, this is the significance of this example 10.2, and you must keep in mind this conclusion. This is important because NCERT each and every point mentioned is important, highlighted the fact that comes into our daily day-to-day life and our industrial purposes. So submarines designed are based on this result, right? Now, atmospheric pressure. To measure the atmospheric pressure, a mercury barometer is used. Mercury barometer. Mercury barometer, and that was made by the person known as the Evangelista Torricelli, 1608 to 1647. Evangelista Gelista Torricelli, or on the basis of his name, one theorem is also there. Torricelli theorem, 1608 to 1647, राइट. बहुत कम साल दिया भाई, 40 years में खत्म होगी कहानी, है ना. So the pressure of the atmosphere at any point is equal to the weight of a column of air of unique cross-sectional area extending from the point to the top of the atmosphere. That is known as the atmospheric pressure. So if someone asks you what is that 1 atm, what is the 1 atmospheric pressure? So it is defined as 1 atm is defined as the pressure due to the air column above you. Air column above you having the cross-sectional area 1 meter square. Unit cross-sectional area 1 meter square. Unit cross-sectional area, right? 1 meter square. And this ATM is nothing but equal to the 1 ATM is equal to 1.013 into 10 to the power 5 Pascal. That means Newton per meter square. You can say it right in the Pascal terms also, right? ये हो गया. So why it is important? Torricelli name why comes into picture here? Because he devised a measuring device that measures the atmospheric pressure. So what he did is that he took a what some this kind of is- measuring instrument. He devised such way that you can measure the pressure of anything. So this is based on the mercury. Why mercury? Okay. See, mercury is the high density liquid, high density liquid. So see, uh, rho gh, pressure equal to rho gh, gauge pressure, p minus pa equal to rho gh, right? So here density play a great role in deciding the shape of the measuring device. Why? Let me first explain this, then I will come to this point. So what he did, Torricelli, what he did is that he took a tub filled up of the mercury. So उसने एक टब लिया, पूरा मरकरी से भरा हुआ था. Mercury is the heavy density fluid. We have discussed previously. And a long glass tube closed at one end and filled with mercury. ठीक है. तो उसने क्या किया कि एक जो है long glass tube, thin, one end is closed, one end that is also filled with the mercury, same mercury. Up to this it is filled, right? So this is also mercury, this is also mercury, Hg, that is poisonous liquid, you know. So he inverted the mercury filled long tube, glass tube, into the mercury bath tub, ऐसे डाल दिया. तो उसने देखा कि भाई मरकरी का एक और खास प्रॉपर्टी बता देते हैं बच्चों आप लोग को. हियर नोट इट, और रुक जाओ जी. हाँ, यहाँ जो ये नोटिस कीजिए, ये जो सरफेस है ये ऐसे है. मतलब जब ग्लास में भरेंगे, एक ग्लास के अंदर मरकरी को लेंगे तो उसका सरफेस जो है ओरिफिस ऐसे बनेगा. ध्यान दीजिए, ये एक मरकरी से फिल्ड ग्लास है, तो उसका जो ओरिफिस होगा वो क्या होगा? कन्वेक्स होगा. क्या होगा? कन्वेक्स. और आप डेली लाइफ में पानी पीते हैं, कुछ ज्यादा ही मोटा बन गया ग्लास, थोड़ा पतला बनते हैं ऐसे. जब पानी पीते हैं तो उसमें पानी भरा होता है ना, तो आप उसका जो है आपने देखा होगा उसका जो शेप होता है ऐसे होता है. समझ गए? ये मरकरी है और ये क्या है? H2O है. दोनों के सरफेस के डिजाइन में ध्यान दीजिए. ये क्या है? कनकेव है. क्या है? ये क्या है? कनकेव है. और ये क्या है? कन्वेक्स है. दोनों का प्रॉपर्टी ध्यान दीजिए. फ्लूइड है, मतलब यहाँ लिक्विड है मरकरी, ये भी लिक्विड है, वाटर है, ये मरकरी है. यहाँ पर इसका जो सरफेस है वो क्या होगा? कन्वेक्स होगा. ये क्या होगा? कनकेव होगा. आपने वाटर तो देखा ही होगा और ये मरकरी भी देखा होगा. कहाँ हो मिलेगा आपको? भाई आपका जो थर्मामीटर होता है, जो आपका बॉडी टेम्परेचर मेजर करता है, वहां मिल जाएगा आपको देखने को. वो हमेशा जो है ऐसे कन्वेक्स शेप में होगा. तो इसकी वजह है मरकरी जो है ग्लास को के सरफेस को नहीं वेट करता है, भिगोता नहीं है, जबकि वाटर से जो ग्लास सरफेस क्या हो जाता है? भीग जाता है. तो एक तो ये है. और डेंसिटी जो है मरकरी की क्या होती है? ज्यादा होती है वाटर की तुलना में. तो इसमें जब ऐसा किया तो ये जो है हमारा क्या है? ये जो सरफेस है ये एटमॉस्फेरिक प्रेशर पर है. ये सरफेस मरकरी का, ठीक है, ये सरफेस क्या है? एटमॉस्फेरिक प्रेशर पर है, 1 atm है. ठीक है. तो ये जो प्रेशर यहाँ पर जो मेजर हो रहा है, वही प्रेशर तो यहाँ पर भी मेजर हो रहा है, क्योंकि मरकरी का ये ट्यूब तो बहुत लंबा नहीं है. तो वही बता रहे हैं, पिक्चर में दिखाएंगे आपको. तो ये मरकरी का जो कॉलम है, इसकी यदि हाइट h है, तो इस हाइट का जो वजह से जो प्रेशर होगा वो क्या होगा, Pa के बराबर होगा, रो जी एच, एंड दैट इज इक्वल टू 1 ATM। ठीक है, उसने बहुत अच्छा से मेजर करने का तरीका ढूंढ निकाला। और ये रो जी एच जो 1 एटमॉस्फेयर है, आप डेंसिटी जो है मरकरी का जानते हैं वैल्यू, जी जानते हैं, और हाइट जो है निकाल सकते हैं। तो हाइट जब निकाला गया तो क्या मिला कि ये 76 वाट सेंटीमीटर आया। दैट्स व्हाई इट इज कॉल्ड दैट 1 atmospheric pressure is equal to 1 atmospheric pressure is equal to pressure is equal to 76 centimeter of height of Hg। इसका डेफिनेशन आ गया। ये चीज हुआ समझ में आया? उम्मीद है कि आप लोगों को समझ में आ रहा होगा। कमेंट कीजिए आपको ये वीडियो आपको कितना अच्छा लग रहा है, और कोई डाउट है तो पूछिए। ठीक है, और ज्यादा से ज्यादा जो है अपने दोस्तों में भी शेयर कीजिए भाई। क्लासेस जो है आप लोग की, अभी टेस्ट भी होगा, तो टेस्ट के लिए आप लोग तैयार रहिए, है ना। आप लोग के एग्जाम्स भी चल रहे हैं, इसलिए मैं आप लोगों को ज्यादा प्रेशर नहीं दे रहा हूँ, लेकिन ये चीजें आपको एग्जाम में आएगी तो आप समझ जाइए कितना इंपॉर्टेंट है और आप लोगों के लिए। तो अभी देखते हैं इसमें कुछ लिखा है कि नहीं। द स्पेस above the mercury column in the tube contains only mercury vapor whose pressure P is so small that can be neglected। तो उन्होंने जो ये मैंने लेफ्ट छोड़ा है, यहाँ पर जो है मान लो मरकरी के थोड़े बहुत जो है वेपर आ गए, तो उनका वेट बहुत कम होगा, इसलिए उनको निगलेक्ट कर देंगे। सो स्मॉल, तो वेट कम होगा, वेपर उनका प्रेशर भी कम होगा, तो हम पी जो है निगलेक्ट कर देंगे। अब देखिए, thus the pressure at point A is equal to 0, the pressure inside the column at point B must be the same as the pressure at the point C। कहाँ गया क्या, ये देखिए, ये प्रेशर और ये प्रेशर जो है क्या है, सेम ही है, सेम लेवल पे है, इसलिए क्या होगा, सेम। आप सोच रहे होंगे कि ये सरफेस जो है, यही मैं नोटिस करा रहा था आप लोगों को, ये जो सरफेस है ये मरकरी का यहाँ से डाउन गया तो क्या हुआ, लेकिन मरकरी ऐसे ही यहाँ पर है, डाउन में ही है, इसीलिए जो है वहां का डाउन दिखते हुए भी क्या है, वो डाउन दिखते हुए भी ये इसके ओपन सरफेस है ये। ठीक है, तो ओपन सरफेस चाहे वो यहाँ ओपन सरफेस हो चाहे वो एटमॉस्फेरिक प्रेशर तो सेम ही होगा ना, उतना माइनर हाइट के लिए हो एयर कॉलम्स के लिए तो नहीं चेंज होने वाला है। ठीक है, तो क्योंकि जब हम एटमॉस्फेरिक प्रेशर डिसाइड कर रहे हैं तो यूनिट एरिया क्रॉस सेक्शनल एरिया की बात कर रहे हैं, और कोई एटमॉस्फेयर की लेंथ को, हाइट को नहीं मेजर कर रहे, कितना हाइट तक जा रहा है। बस ये करा कि हाइट एबव यू एयर कॉलम, हाइट ऑफ द एयर कॉलम एबव यू हैविंग द क्रॉस सेक्शनल एरिया 1, बस इतनी बात कर रहा है। तो यहाँ और यहाँ पर प्रेशर जो है क्या होगा, पीए के बराबर होगा, और ये पीए जो है इससे मरकरी के वजह से जो हमारा हाइट है और जो गेज प्रेशर होगा उसके बराबर हो जाएगा, तो वहां से निकल गया। ठीक है, हम लोग चलते हैं, ये जो एक्सपेरिमेंट है इसको हम लोग समझते हैं। पहले तो हमने ये देखा कि जो हमारा जो ये एटमॉस्फेयर प्रेशर जो है यहाँ पी इक्वल टू रोजीएच आ गया। ठीक है, ये हमारा जिस पर क्या किन बातों पर डिपेंड करता है, डेंसिटी ऑफ मरकरी और एच, हाइट ऑफ द एयर। ठीक है, अच्छा हम आपको एक पॉइंट बताना चाहते हैं, यहाँ पर नोट कीजिए पॉइंट क्या है। आप देख रहे हैं कि हमारा जो गेज प्रेशर है वो रो जी एच फैक्टर पर डिपेंड कर रहा है। तो आप किसी भी चीज का यदि प्रेशर मेजर करना चाहते हैं तो वो जो वैल्यू होगी कुछ ना कुछ प्रेशर डिफरेंस देगी। मान लो ये हो गया डेल्टा पी मेजर करना है, और आपको जो है इन टर्म्स ऑफ रोजियत ही मेजर करना है, रोजित ही मेजर करेंगे। तो मान लीजिए आप कोई डिवाइस बना रहे हैं, तो उस डिवाइस में फ्लूइड कौन सा लेंगे ये जरूर सोचना पड़ेगा, क्योंकि यदि आप डेंसिटी ज्यादा लेते हैं और अप्रिसिएबल जो है डेल्टा पी कुछ ठीक ठाक वैल्यू रखता है, तो डेल्टा पी मान लो आपको 10 एटमॉस्फेयर के बराबर है, तो 10 एटमॉस्फेयर को के लिए हाइट जो है और रो, जी तो कांस्टेंट है, इसमें वेरी क्या कर सकता है, जी रो एंड एच, जी इज कांस्टेंट, ये तो नहीं वेरी करेगा अर्थ सरफेस पे, तो फॉर द गिवन प्लेस ये तो कांस्टेंट, लेकिन रो और एच जो है वेरी करेगा टू एडजस्ट दिस प्रेशर डिफरेंस। ठीक है, तो आप मान लीजिए आपका कुछ खास अप्रिसिएबल प्रेशर है और आपने डेंसिटी लो डेंसिटी का फ्लूइड ले लिया, तो हाइट जो है बहुत ज्यादा हो जाएगी टू एकोमोडेट दिस प्रेशर डिफरेंस। तो बहुत ज्यादा हाइट हो जाएगी तो भाई इंस्ट्रूमेंट कैसे डिवाइस करेंगे। तो इस बात का ध्यान रखना है कि जब हम इंस्ट्रूमेंट डिवाइस कर रहे हैं, बना रहे हैं, तो हम डेंसिटी फ्लूइड की यदि ज्यादा बढ़ा हाईवी डेंसिटी वाला फ्लूइड ले लें तो हमारा एच कम हो जाएगा टू एडजस्ट द डेल्टा हाई डेल्टा पी। तो इस सब चीजों का ध्यान रखना है कि कब हमें जो है हाई डेंसिटी का फ्लूइड लेना है, कब हमें लो डेंसिटी का फ्लूइड करना है लेना है, क्या हम मेजर करना चाहते हैं, किस तरह के प्रेशर को, ज्यादा डिफरेंस वाले प्रेशर को मेजर करना चाहते हैं या कम प्रेशर डिफरेंस को मेजर करना चाहते हैं। ज्यादा डिफरेंस को मेजर करना चाहते हैं तो आपको हाई डेंसिटी का फ्लूइड लेना पड़ेगा, और कम का मेजर करना चाहते हैं तो कम से ही हो जाएगा। ठीक है, तो आ, जो इंस्ट्रूमेंट प्रेशर मेजर करता है उसको माइनोमीटर कहते हैं। ठीक है, ये माइनोमीटर है। ठीक है, तो ओपन ट्यूब माइनोमीटर, तो इन्होंने टोरिसोली ने एक्सपेरिमेंट किया, क्या किया देखो। इन द एक्सपेरिमेंट इज बी फाउंड दैट मर्करी कॉलम इन द बैरोमीटर हैज हाइट ऑफ अबव, ये तो हमने करा दिया है। और ये नोट कर लो, ये प्रेशर इक्विवेलेंट टू mm इज कॉल्ड टोर, ये एक नया फार्मूला है, इसको नोट कर लेना। अ प्रेशर इक्विवेलेंट टू ऑफ 1 mm इज कॉल्ड ए 1 टोर। ठीक है, तो टोरिसोली के रिस्पेक्ट में 1 टोर का डिफिनेशन दिया गया है। 1 टोर इज इक्वल टू, टोरिसोली के डिफिनेशन 133 पास्कल, and 1 atm is equal to 1.013 into 10 to the power 5 पास्कल, ये तो आपको पता है। ठीक है, तो ये इतना पास्कल जो है 1 एटीएम में होता है, तो आप इसमें से कितना हो गया, ऑलमोस्ट जो है कितना हो जाएगा, कितना पास्कल एटीएम हो जाएगा 1 टोर में, 133 इंटू 10⁻⁵। ठीक है, रिवर्स करेंगे तो, मगर अभी के लिए आप इतना नोट कर लो कि 1 टोर जो है, टोर इज आल्सो द यूनिट ऑफ प्रेशर, टोर इज यूनिट ऑफ प्रेशर, इज यूनिट ऑफ प्रेशर, ये आ सकता है एग्जाम में। टोर, टोर इज यूनिट ऑफ प्रेशर, टोर इज यूनिट ऑफ प्रेशर, दैट वैल्यू इज 133 पास्कल। और ये जो है 1 mm के प्रेशर इक्विवेलेंट ऑफ 1 mm, तो 1 mm क्या, 1 mm ऑफ मर्करी, वैसे 176 सेंटीमीटर ऑफ मर्करी इक्वल टू 1 एटीएम, वैसे ही 1 mm ऑफ मर्करी इक्वल टू 1 टोर, 1 टोर, 1 mm ऑफ मर्करी इज इक्वल टू 1 टोर। ठीक है, और इसका इस्तेमाल कहाँ होता है, ध्यान दीजिए नीट वाले बच्चे, द mm ऑफ मर्करी एंड टोर आर यूज इन मेडिसिन एंड फिजियोलॉजी। तो ठीक है, इन मेट्रोलॉजी ए कॉमन यूनिट इज द बार एंड मिलीबार, लेकिन जब बड़ा ये स्मॉल स्मॉल प्रेशर डिफरेंस मेजर करने के लिए, जैसे आपका बीपीन मेजर करना है तो स्मॉल प्रेशर होता है, कोई कोई इतना बड़ा ज्यादा प्रेशर तो होता नहीं, उसको मेजर करने के लिए मेडिसिन सेक्टर में, फिजियोलॉजी में हम टोर का इस्तेमाल कर लेंगे। ठीक है, तो 1 टोर इजकल टू 1 mm ऑफ एच जी, 1 mm थोड़ा एच जी बड़ा, इसका मतलब 1 टोर का प्रेशर डिफरेंस क्रिएट हो गया। ठीक है, तो हम लोगों ने क्या सीखा, 1 टोर, 1 टोर इज इक्वल टू 133, हाँ 133 पास्कल, एंड दिस 1 टोर इज इक्वल टू 1 mm ऑफ एच जी। और ये इसका इस्तेमाल जो है मेडिसिन में, फिजियोलॉजी में इस्तेमाल होता है हमारे। ठीक है, नेक्स्ट पॉइंट क्या है? फॉर द मेट्रोलॉजी पर्पज वी यूज द बार। 1 बार इज इक्वल टू 10⁵ पास्कल। और ये ज्यादातर आपके फिजिक्स में इस्तेमाल होता है, बहुत न्यूमेरिकल वगैरह जो है बार में ही देता है। सो 1 बार इज इक्वल टू 10⁵ पास्कल। ठीक है, और 1 × 10⁵ पास्कल इज 1 ATM। तो 1 बार इज इक्वल टू क्या हो गया? 1 ATM हो गया। क्यों भाई? क्योंकि 1 ATM इज इक्वल टू, हमने अभी पढ़ा ना, 1.013, ऑलमोस्ट 10⁵ पास्कल। तो ये जो है 1 के बराबर है ना ऑलमोस्ट, इसीलिए का नियरली इक्वल टू 1 ATM हो गया। नोट इट, फाइन। ठीक है, तो ये क्या हो गया? 1 बार इज इक्वल टू 10⁵ पास्कल, दैट इज नियरली इक्वल टू 1 ATM। एंड ओपन ट्यूब माइनोमीटर इज यूज्ड इंस्ट्रूमेंट फॉर मेजरिंग द प्रेशर डिफरेंसेज। तो ये ओपन ट्यूब माइनोमीटर क्या है, देख लीजिए, इसको डिजाइन देखिए। पहले आपको एक छोटा सा ब्रीफ कर देते हैं इस इंस्ट्रूमेंट का। हाँ, प्रेशर डिफरेंस मेजर करने के लिए इस्तेमाल होता है। जिस भी चीज का प्रेशर डिफरेंस पता करना चाहते हैं, कितना प्रेशर है उसके अंदर, तो उसको जो है इस एंड पर अटैच कर देते हैं, पॉइंट ए पर। ठीक है, थोड़ा बड़ा कर देता हूँ। हाँ, ठीक है। तो जिस भी चीज को अटैच फाइंड करना होता है प्रेशर डिफरेंस, उसको हम ए पॉइंट पर, ये जो यू ट्यूब शेप में है, ओपन यू ट्यूब, ओपन ट्यूब, तो ये यू शेप है, यू शेप है ना, ये क्या है? यू शेप है। ठीक है, कहाँ गया भाई? ज्यादा ऊपर चला गया। हाँ, यू शेप में है और ओपन ट्यूब है। देखिए, जो इसका जो है एक हेड जो है, एक एंड जो है लॉन्ग है, एक शॉर्ट है, और इसमें जो है कोई भी फ्लूइड भर सकते हैं अपनी इच्छा के साथ। डिपेंड करता है कि डेंसिटी हमें किस तरह की लेनी है, किस तरह, कितना प्रेशर मेजर करना है। तो लो प्रेशर मेजर करना है तो लो डेंसिटी का चलेगा, हाई प्रेशर मेजर करना है तो हाई डेंसिटी का फ्लूइड लेना पड़ेगा, सो दैट टू मेंटेन द हाइट। ठीक है, जब अटैच कर देंगे तो इनिशियली जो है इसका जो प्रेशर होगा, ये जब यहाँ नहीं रहेगा तो क्या होगा? ये प्रेशर जो है, ये प्रेशर जो फ्लूइड क्या है, बराबर में रहेगा। लेकिन जैसे ही इससे अटैच करेंगे और यदि इसका प्रेशर ज्यादा है 1 ATM से, तो क्या होगा? ये प्रेस करेगा और इधर का कॉलम ऊपर चला जाएगा। ठीक है, चला जाएगा। जब कितना गया, इसके लेवल से कितना ऊपर गया, उस और इस लेवल के बीच में हाइट को हम मेजर कर लेंगे। ठीक है, हाइट पता चल गया, डेंसिटी हमें फ्लूइड का पता है ही, तो हम जो है इस रोजियस के फॉर्मूले से क्या कर लेंगे? उसको मेजर कर लेंगे। और जो ये है वो वैल्यू क्या होगी? ये एक्स्ट्रा वैल्यू इसकी वजह से ही तो आई है, इस इसकी वजह से ही आई है। और ये जो है आपको पता चल जाएगा कि जिस भी बॉडी का आप प्रेशर मेजर करना चाहते थे, उसकी वैल्यू जो है इतनी है, क्योंकि इनिशियली इट वाज ए एंड बी वर इक्वल, बट when you connect this body to the open end here, so it raises the level of the fluid in the other end of the tube. So आप प्रेस हाइट डिफरेंस को मेजर करके आप जो है कर सकते हैं। तो देखिए, यहाँ जो चीजें मैंने बात किया है वो दिया हुआ है, ट्यूब कंटेनिंग ए सुटेबल लिक्विड। सुटेबल लिक्विड का मतलब यही है। सुटेबल लिक्विड मतलब क्या? सुटेबल लिक्विड मतलब हमारे ऊपर डिपेंड करता है कि हम क्या लेना चाहते हैं। सुटेबल लिक्विड लेंगे, वो सुटेबल लिक्विड इस बात पर डिपेंड करेगा कि हम कितना प्रेशर डिफरेंस का चीज मेजर करना चाहते हैं। ए लो डेंसिटी सच एज ऑयल फॉर मेजरिंग स्मॉल प्रेशर डिफरेंस, एंड हाई डेंसिटी सच एज मर्करी फॉर लार्ज प्रेशर डिफरेंस। आप समझ ही गए होंगे भाई, यहाँ पर लार्ज प्रेशर डिफरेंस है यहाँ पर, ठीक है, और आपने लो डेंसिटी ऑयल लिक्विड ले लिया, तो क्या करेगा भाई? लार्ज प्रेशर है तो उसने लार्ज प्रेशर डिफरेंस किया, तो अपने रोजियस रो तो लो ले लिया आपने, तो प्रेशर को इक्वल करने के लिए एच को ज्यादा होना पड़ेगा, तो एच बहुत ऊपर होगा। पता चले जो है 10-20 मीटर का एच चला गया, तो आप उतना लंबा ट्यूब कहाँ से लेंगे? नहीं लेंगे। तो मेंटेन करने के लिए क्या करेंगे? आपने हाई डेंसिटी का मरकरी ले लेंगे, तो आपका जो है एच जो है लिमिटेड हाइट में आएगा, आप कैलकुलेट कर लेंगे। one end of the tube is open to the atmosphere, ये open रहता है, open to the atmosphere exposure है, and another is connected to the system whose pressure we want to measure. The pressure P at A is equal to pressure at point B initially. ठीक है, what we normally call is the gauge pressure. ठीक है, लेकिन P minus PA is that is rho GH. तो ये जो P और PA A और B है, PA और PB क्या है, इनिशियली इक्वल था. ठीक है, इनिशियली. ठीक है, और ये जो है जैसे उसमें कनेक्ट होगा वो जो है P माइनस PA जो है क्या हो गया, बताएगा कि कितना प्रेशर है इस सिस्टम का जिसको मेजर करना चाहते हैं. ठीक है, नाउ अभी क्लोज करने वाले हैं. देखिए, फॉर लिक्विड द डेंसिटी वैरीज वेरी लिटिल ओवर वाइड रेंजिंग प्रेशर. अब जो है आप ये सोच सकते हैं, यहाँ पॉइंट नोट करना है कि व्हाई वी आर टेकिंग लिक्विड इन द मैनोमीटर और बैरोमीटर टू मेजर द प्रेशर डिफरेंस. व्हाई नॉट गैसेस? So answer is obvious that since liquids are incompressible, so when the even high pressure is applied, the liquid is not going to get pressed. But gas, in case of gases, they can be compressed easily, so they will not be able to measure the real pressure. So that is the reason. You mind it, note it. The question may be asked in such a way, a certain reasoning question type. So why you are using the liquid? Why not gases for measuring the pressure? So the answer is the compressibility. कंप्रेसिबिलिटी किसकी ज्यादा है, किसकी कम है, इस बात का ध्यान करके आंसर जो है हम लोग कर देंगे. ठीक है, फॉर लिक्विड द डेंसिटी वैरीज वेरी लिटिल ओवर ए वाइड रेंज ऑफ प्रेशर एंड टेम्परेचर एंड वी कैन ट्रीट इट सेफली एज ए कांस्टेंट फॉर आवर प्रेजेंट पर्पज. बट गैसेज ऑन द अदर हैंड एग्जिबिट्स द लार्ज वेरिएशन ऑफ डेंसिटी विद चेंज इन द प्रेशर एंड टेम्परेचर. तो उनका कंप्रेसिबिलिटी की वजह से डेंसिटी बदल जाएगी और टेम्परेचर बदलने से भी उनकी डेंसिटी बदल जाती है. ठीक है, क्यों भाई? यदि गैस है और उसको हीट कर देंगे तो क्या होगा, फैलेगी, एक्सपेंड करेगी. अगर लिक्विड इतना जल्दी एक्सपेंड नहीं, बॉयल करेगा, एक्सपेंड तो नहीं करेगा. ठीक है, गैस बनेगा तब, मतलब वो जब चेंज होगा तब. जब तक लिक्विड है तब तक कोई टेम्परेचर का फर्क नहीं पड़ेगा, लेकिन गैस को थोड़ा भी गर्म का एक्सपेंड कर देगी, डेंसिटी कम हो जाएगा. इफ इट हैज द इनफ स्पेस, राइट. सो देयरफॉर वी यूज लार्जली एज ए लिक्विड फॉर मेजरिंग द प्रेशर, राइट. चलिए, ये सारी चीजें हो गई. अब जो है हम लोग जो है ये प्रॉब्लम्स जो है नेक्स्ट क्लास में करेंगे. उम्मीद है कि आप लोगों का ये वीडियो एक्सप्लेनेशन लेक्चर जो है आपको समझ में आया होगा.